All right, so today we're going to finish up with section 2.1, and we're going to look at a little bit of 2.2. It's still about the same amount of slides as it was yesterday. It's fine. So that's pretty typical. So what I want to look at first is let's graph that equation. And what I want to focus on is how many times it crosses the x-axis. All right, so it's 2x cubed minus 3x squared minus 3x plus 2. Okay, I did zoom 6. I already know I did that ahead of time, so it's a standard window. Standard window is perfect. Tells me exactly what I want to know. And what's the answer? How many times does that graph cross the x-axis? Max?
It's 3?
Yeah, it's 3 times. So it crosses 3 times. And what I want to do is look at each point where that graph crosses the axis. You've got a point here, here, and here. If you were to write those 3 points as coordinates, what would be the y value of each one of those red dots? Yeah? 0. Where a point crosses the x-axis, the y value is 0. What are the x values? Well, I don't know. I have to find those. I could find them. But I know the y value is 0. What we're going to be focusing on is called finding zeros, or finding roots of equations, or finding x-intercepts. All those things mean the same thing. So if I took a simpler equation, and I said to you, what is the 0 of this function? It would be the number that you can plug in for x so that you get an answer of 0. And in this case, it would be 2. 2 is the 0 of this polynomial function. It's the number you plug in for x, and you get 0 for y. Another way to say it is 2 is the x-intercept if you were to draw this. 2 is the number where it would cross the x-axis. It means the same thing. Jess, can you just shut down for me? Thank you. So, this part, I'm just going to write this down. I'm not going to show it. What I want to do with it is more important than showing it. But 2x cubed minus 3x squared minus 3x plus 2. It will equal that. If you don't know how to do that, that's okay. Okay, that's factoring. It's a little bit more complicated factoring because it's not a highest exponent of a 2. So it factors into 3 sets of parentheses. Regular factoring is only 2. But the important thing is, I just want you to know that this is equal to that. The way you'd prove it, you would FOIL it out. And if you FOILed out what's in the black parentheses, you would get what's in red. Okay, so just trust me. What I want to point out, though, is the way that it is written in black, once you know how to do that, which is something we're going to look at in later chapters. This is a much better way to write it when you write it factored. Because if we can factor it into sets of parentheses, it makes it very easy to find the roots. It makes it very easy to figure out where does the graph cross the x-axis. And that's the part we're going to do. So let's look at how you can figure out where a graph crosses the x-axis if you are able to factor it. Okay? So in a problem like this, I would give you that black box. I would already factor that part for you, especially if the exponent was a 3, because that's hard to do. Okay, so we've got x plus 1, 2x minus 1, and x minus 2. And I want to know, where does our formula equal 0? That's what I'm trying to figure out. One thing I could do real quick, just to show you, is I could type in x plus 1, 2x minus 1, and x minus 2. And just watch it draw it. If it's the same, it should trace exactly on top of it. And if you watch, the blue graph is going to turn red. That shows you it is exactly the same thing. But this way is better. Because if you multiply something times something times something and you get 0, what must have to happen? If you multiply 3 things together and you get 0 as the answer, yeah?
One of them has to be 0.
One of them has to be 0. Either this one has to equal 0, or this one has to equal 0, or this one. So there are 3 possible options. What could we plug in for x to make this first one 0? Yep. Negative 1. What could we plug in for x to make the second one 0? Yep. 1/2. Very good. And what could you plug in for x to make the third one 0? Yep. 2. Let's look at that picture again. What do you notice about those 3 numbers we just found when you look at the picture? Max?
They line up with where it crosses the x.
Those are the numbers where it crosses the x-axis. Negative 1, 1/2, and 2. Without being able to write it with sets of parentheses in a factored way, it's not very easy to figure it out. You have to be able to write something like that in that form. Okay? That's the whole way this method works. So those 3 numbers that we found, negative 1, 1/2, and 2, those are called the zeros of the polynomial. They're also called the roots. They're also called the x-intercepts. Same thing. It's basically what I just said to you. So if you find a number that you can plug into a formula and it gives you an answer of 0, then you just found a root to your equation. Or you also found a 0. If you write it as that number, comma 0 in a coordinate format, now you're describing an x-intercept. But those 3 terms basically all mean the same thing. Yes?
If you are answering a problem and it asks you to find the roots and the intercept is 0 or whatever, how would you, say you got those 3 answers, how would you write that out in a appropriate manner to express these questions?
So in this one, they said find the exact solutions to f of x equals 0. You would just write x equals, and x equals. That's how you would write it.
If you were asked to find the roots of the zeros, would you do it?
You do it like that.
Do it like that.
If it said to find the x-intercepts, technically you should write your answers as coordinates.
Okay.
Negative 1, comma 0. Negative 1/2, comma 0, 2, comma 0. Because an intercept is a location on a graph, and that is a coordinate. So it'd be slightly different, but very, very similar. So let's look at this equation, a little bit simpler than the one we just did. It's a linear equation. And to solve a linear equation, you don't have to factor it. Linear is simple enough that you can do it without factoring. Once you get harder than linear, like cubic, that's the one we just did, you have to factor. But for linear, all you'd have to do, like if you had a problem like this, actually I think that's the one we're going to do, is bring the 5 to the other side by subtracting it, and then divide by the number in front of x. That's what this is saying. Minus the b to the other side, and then divide by the number in front of x. That's, in general, how you solve a linear equation. If it's that simple, it's only 2 steps. So I think 2x plus 5 equals 0. That might be the exact one I'm going to do. No, it's 2x plus 3 equals 0. Little bit. So, it's set equal to 0, so what you're doing is you're finding the roots. How would I get x by itself in that equation? What would be my 2 steps? Jess?
You would subtract 3 and then you would divide 2 for -3.
Yep, so what would your answer be?
3 over -3 over 2.
Yep, good. -3, and then you divide by 2. And that is called the root of this equation. It's also called the 0. If you write it as a coordinate, it's called the x-intercept. Questions on that? So, one step up from linear is quadratic. Not as complicated as the first one we did that had an exponent of 3, but a little more complicated than the last one we just did, which was linear. Does anybody remember what the shape is called when you draw a quadratic? Chris? It's a parabola. And how many times can a parabola cross the x-axis? At most. Yep.
Twice at most.
Yep, twice at most. Is there any other situation that can happen besides twice? Yep.
Once or none.
Once or none. So we talked about a quick way that you can tell how many times it crosses. I think this was at the end of section 1.5. So not Wednesday's lesson, but Tuesday. You check b squared minus 4ac. If it comes out greater than 0, it crosses twice. If it comes out less than 0, it doesn't cross at all. And if it comes out equal to 0, it crosses once. So the 0 crossings could look like that. 1 could look something like this. And 2 could look like that. So one way that we can try to, well, there's 2 main ways we can solve quadratics. We can try to factor them with 2 sets of parentheses. Or, what's the other way you can solve a quadratic if it's not factorable? Anybody remember the name of the formula you can use? Yep.
It's a quadratic formula.
Yeah, the quadratic formula. So if you can't factor something, you can use the quadratic formula. Now, when I see a problem and it says solve approximately doesn't mean they need an exact answer. The quadratic formula will give me an exact answer. But if they say solve approximately, I'm not going to use quadratic formula. I'm going to use the calculator because it's faster. The downside to the calculator is it will not give you an exact answer. The calculator is going to give you a decimal. But that's fine, because they said it only has to be an approximate answer. If it said exact answer, then I'm going through the whole quadratic formula. Okay. So let's try this one. And I want to do this the same way we did the last problem. The last problem was set equal to 0 when we went to solve. So let's do that here. Quinn, how can I get this with 0 on one side?
Just subtract 1 and add 2x to both sides.
Okay, we could move everything to the left, sure. Subtract the 1. Okay, that's gone. And add the 2x. And that's gone. Instead of writing it vertical, let's just write it out horizontal. So we have 2x squared plus 2x minus 1 equals 0. Let's type that in. We're going to graph it and see what we get. Now remember, we could cross 0, 1, or 2 times. So 2x squared plus 2x minus 1. Yes?
What happens if you just subtracted 2x squared from both sides?
You could do it that way as well. You get the same answer.
Would 2x not be negative?
Well, it would be negative 2x squared minus 2x plus 1. But if I type that in, it's going to cross the x-axis at exactly the same spots. It won't make a difference in the answer. Okay, so how many solutions are we looking for here? Yep, 2. Have we done second calc 0 yet? Done that? So the calculator has a function built in to calculate where it crosses the x-axis. It's called 0. It's the same menu you'd use when you do intersect. I know we did intersect. And it asks you the same kinds of questions. It's going to ask you 3 questions after you pick 0. The first thing it says is left bound. You need to pick somewhere that is to the left of where it crosses the x-axis. We have to do it twice. Okay, we have to do it as many times as it crosses. So move your cursor to the left, hit enter, and it should put a dotted line to the left of where you're trying to find. I'm trying to find this one. That's the one I'm doing right now. Okay, next, move your cursor to the right and hit enter. And now you should have 2 dotted lines with the place where it crosses right in the middle. And the last thing is the guess. The guess doesn't really matter in this case. So you can just hit enter. And it gives me an answer of negative 1.37. That's not an exact answer, but that's okay. It's approximate. If you want the exact one, you're going to have to do quadratic formula. And you'll end up with something like 2 plus or minus square root 5 over 7. You know, something like that. I just made that up. Any questions on how I got that one? Okay, do it one more time. So now we're going to find x2. I'm just calling it my first answer and my second answer. Go here. Second calc 0. Pick a point to the left. Hit enter. Right. Hit enter. And do my guess. And the other answer is 0.37. If you see anything on the test and it doesn't tell you where to round, generally, if you use 2 decimal places, you're going to be fine. So if there's any problem on the test and it doesn't say, use 2. Any questions on that? Those are my 2 roots, or those are my 2 zeros. They're also my x-intercepts. Same. So what we just did was an example of finding a root graphically. Okay, I'm going to skip this because you don't even have to write this part because we already did it. Let's try one more of those. Again, it says approximate. So first thing I want to do is get it equal to 0. And now I'll solve it. Sorry, it should be a plus sign. Now, this is a cubic. This is like the first one we did. How many times did that first one cross the x-axis? Max? 3 times. Cubics generally look well, there's a couple ways they can look. That's one way, where it only crosses it crosses 3 times. You can get 2 if you had something like that. You can also get 1 if you had something like that. Sometimes this middle part is just more of a bend. In these 2 cases, the middle part is an actual turn. Like it's going up, it turns, and then it turns again. Sometimes it doesn't quite turn. It just bends a little bit. So let's draw it and see like which one of these we have. But it's going to be one of those 3 types. Okay, so x cubed plus 2x minus 1. Okay, I'm still on Zoom 6. I think that's going to be okay for what we're doing. And if you look at it, how many times does it cross the x-axis?
Once.
Yep, just once. So it ended up being more like this third one at the bottom. Just crosses 1 time. And it's got kind of a bend in it, but it never really turned. Okay. Can somebody tell me the buttons I press to find the 0? Yeah, go ahead.
Second, and then count.
Yep.
And then you press the number 2.
That's number 2. Got it.
And then for left bound, you go a little to the left of the 0 that you look at.
Yep, I'm there.
Press enter. And
Press
then
enter.
Go to the right a little bit.
Okay.
And then you press enter.
Press enter.
And you go like somewhat in the center of both of them.
Yeah. And press enter. And you should get a 0 in this problem of 0.45. There's your answer. Okay, questions on that? Okay, so that's using the calculator to find a 0. Alright, so 3rd degree polynomials. This is the most complicated type we're going to look at today. We already looked at it in the very first one that I did with you. It's the one that factored into 3 sets of parentheses. I already gave you guys kind of an idea of what 3rd degree polynomials can look like. But the general concept is they go up forever and they go down forever. It's not like a parabola. A parabola either goes up and up, or if it flips, it's down and down. Cubics, mainly because they're odd as the highest exponent, go up on one side, down on the other. Sometimes the middle part takes a turn. Sometimes the middle part is just kind of a bend, and it never really does a turn. But that's basically what every cubic looks like. One of those 4. The turn could be a little sharper or something, but they all fit into one of those 4 groups. And when you write a cubic, sometimes you don't have every single term. This is a cubic. It's a cubic where A is 4, B is 0, C is 0, and D is 0. That's okay. It's just a simpler cubic. It doesn't have all the other terms with it. Generally, if it doesn't have the other terms with it, it's going to be one of these that has a bend in the middle. You start getting these turns usually when it gets more complicated. So we're going to look at a cubic, and the first thing we're going to figure out is how many solutions it has. Make sure you don't confuse that with what the solution is. How many is just how many times does it cross. The next question is going to be, what is the solution? Okay, so here's our equation. I would expect that's a little more complicated, so it potentially could have more turns in it than just a bend. Maybe. It just depends. Let's graph it and see. So we got x cubed minus 5x squared plus 6x minus 1. Okay, I've been doing everything with Zoom 6 today, and that seems to have been fine. So as I expected, it is a little more complicated, so it does have the bend in it. It has turns. And Alva, how many solutions do you think that equation has?
3.
3. Yeah, if we're looking for where it equals 0, that means we're looking for where it crosses the x-axis. I see 1, 2, 3. So that's the answer. 3 solutions. Now, the next part was to find one of them. Does anybody have a question on how to find a root? We've already done it twice. But does anybody want to see it a third time? How to do the second calc 0. Okay, and we'll skip example 6. Okay. So if I asked you this on a test and I said find the middle root, I mean this one. If I said find the left one, I mean that one. If I said find the right one, then I mean that one. Okay, it'll be clear which one I want you to find if I only want one of them. Otherwise, you just write them all. Any questions on that? All right, so that was the longer part of what we're going to do. And we're going to finish up with one type of question from this section. So this part focuses on kind of what we've been doing, using the graphing calculator to solve a problem. Remember, when you want to use the graphing calculator, sometimes you have to set your window. We didn't do a lot of window setting in the last section, so I'm going to do a problem in this section where you do need to adjust your window. So when we want to solve something, usually you always end up making some kind of equation. That's all that this is saying. When you're trying to solve a problem in math, part of the solution is always making an equation. That's algebra. How you solve this equation, well, there's lots of ways. Sometimes you finish solving the equation with algebra. Sometimes you might do a graphical approach. And that's what we do a lot of with the calculator. So in the problem we're going to look at, it's going to involve making an equation first, and then we'll use the graphing calculator to solve it. So it's not really anything specific. It's pretty general about what this section is about. That's all. All right. And this is going to be the last problem we do. Okay, so we'll do a couple things with it. First part, we'll come up with an equation. Second part, we'll solve it. Okay, so this problem is going to be about somebody who is investing. They have an amount of money to invest, and they're going to invest it in 2 different investments. So in this case, Bill has $20,000 to invest. He's going to take some of that money. This is the question I'm going to want to know, how much. But for now, he's going to take some of that money, and he's going to invest it in something that pays 6.75% interest. specifically simple interest. If you don't know what simple interest is, that's okay. I'm going to give you the formula for it. This is a formula I would give you on a test. You would not be expected to memorize it. So he's going to take some of his money and invest it at an account that pays him 6.75% interest. He's going to take whatever's left over after he invests in the first account, and he's going to dump the rest of it in the second account. The second account pays 8.6% simple interest. Now, in order to do this problem, you need to know what the formula is for calculating how much money you would make if you invested in a simple interest type of thing. That's the formula. It's I equals P R T. So it has 4 letters. Let me show you what each letter stands for. I is the interest. That's how much money you make. So like if you put money in a bank account and you don't touch it, and you go back and look at it in like 5 months, you might see that you have a little more money in there than you had 5 months ago. That's because the bank gave you interest. So I is the interest. P is the principal. Principal is how much money you're putting in. $200, $2 million. How much did you put in the bank? R is the rate that your investment pays. What's important is it's a decimal. So for example, 12% would be 0.12. Have to change the rate to a decimal. And T is the time, usually measured in years. So what they want us to do is find an algebraic representation, that just means write an equation, that represents the amount of interest Bill earns in 1 year. Now we're going to need a variable. We don't know how much money he's putting in the 6.75% account, and we don't know how much money he's putting in the 8.6% account. But we're going to pick a variable to represent one of them. You don't need a variable for both. You only need it for one. So let's let X be the amount of money that Bill invests at 6.75%. That's his principal. It's what he's putting into the first account. So how many accounts is Bill investing in? Yep, he has 2. He's going to make money from 2 different things. So let's start by figuring out how much money he makes from the first one, the 6.75%. So we need the formula I equals PRT. Well, I we don't know. That's what we're trying to figure out. Principal is how much money he invests in the 6.75% account. How are we representing the amount of money he puts in the 6.75% account? Yeah, X. That's the principal. What's the rate on this account? I know it's 6.75%. But what would I fill in for R? Yep.
0.0675.
Yep. 0. A little more space. 0.0675. That's how you write 6.75%. So there's your rate. And what's the time in this problem?
1 day.
One what?
Oh, 1 year.
1 year. So we actually don't even need times 1 at the end because that's not going to change anything. So there's your formula for the interest he'll make in this account. Interest equals, let's write it how we normally would. We would put the number in front of the letter. So that's the first account. Now let's do the second account. So first thing we need is the principal. How much money does Bill have to use here? What's his total amount of money he has to play with?
20,000.
He has $20,000. How much of it did he already put somewhere? Yeah?
X.
He already put X dollars somewhere. So what does he have left now? That's what's going to go in this account. Yep.
20,000 minus X.
20,000 minus what he already used up. So 20,000 minus X is the principal. What's the rate on this account? 0.086. And lastly, what's the time again? It's still 1 year, so I don't need to put times 1 at the end. What I do want to do, though, is distribute that out to simplify it. So we've got 20,000 times 0.086. That gives me 1,720. And 0.086 times the negative x. That's negative 0.086x. So I wrote it in y equals mx plus b form. So I changed the order a little bit, but that's how we would normally see it. So now, if you told me how much interest he made, or how much money he wanted to invest at 6.75%, I could plug it into this formula and tell you the interest he makes there. Then I could separately plug it into this formula and tell you the interest there. But he's doing both of these accounts, and he's making money in both. So what would I have to do with the interest he makes here and here to get his total? I would add them. So the total interest is going to be the money from the first account, 0.0675, and the money from the second account, negative 0.086x plus 1720. I do have some like terms I can combine, just the x's. So 0.0675 minus 0.086. That's negative 0.0185. Plus 1720. So there's a formula now for the total. So if you said to me he invested $1,000 in the first account, all I'd have to do is put in 1,000 right there. Multiply and add 1720, and there's my interest. Any questions on first getting that equation? It's all based on I equals PRT. Okay, so when we go to solve it, it's important we understand that only certain values make sense. Yes, algebraically, you could fill in any number you wanted for x. 12, 2 million, negative 17. But in our word problem, x is an amount of money that's invested. So what values would not make sense in our actual problem? Yeah?
Something more than 20,000?
Yeah, we can't go more than 20,000 because he doesn't have more than 20,000. And what else would make sense?
Negative numbers.
Negative numbers. There's your window. X goes from 0 to 20,000. So it's important to understand in our problem, there are restrictions we need to pay attention to. That's what I'm getting at here. And that restriction is going to help us to answer the question we're going to do. So we're going to do it on the calculator. And I told you it would be one where you have to adjust your window. So again, this was just more of a discussion. There's really nothing to write down other than you understand what I mean by what we just discussed. Okay. So now, it says that Bill earned a total of $1,509.10. How much did he invest in each account? So we need that formula from the other page. I need to go back to it just to get it for a second. Negative 0.0185x. Five? Is it 5?
This
5, okay. And then plus 1720. Okay, so there's the total interest. And that's the formula that would calculate it, but we already know what it is. So what would we set that equation equal to? About, Elijah, what would we set that equal to?
Zero. For which equation?
Well, if we set that equal to 0, then we're saying he made no money at all. Because this is the formula that's going to calculate how much interest he earned.
Oh, the interest. Shouldn't the interest be positive?
It is a positive number, but I want to know exactly what positive number. How much interest did he earn?
I have no idea. So the interest rate is the 0.01.
Well, this is the formula that builds in both interest rates. We have one at 6.75 and one at 8.6. So that was the last part. We combined all that information into a nice little formula that will calculate the total interest earned. But we know how much interest he earned. So what am I going to set that equation equal to?
1,500.
Right. What we're solving for is the x. We want to know how much money, well, x specifically is what? How much money that was invested at the 6.75. But if I know how much money was invested in one account, and I had a total of 20,000, well, then I can figure out the other account. Okay, so let's solve for x. Okay, and it says specifically use the graphing calculator. Okay. Algebraically, I'm sure you guys could solve that very fast. Just minus 1720 and divide by 0.0185. Negative. But let's just practice setting the window one more time. So this time we're going to do 2 graphs. When we calculate something with 2 graphs, does anybody remember what we're usually looking for? It's not a 0. Yep. We're going to look for an intercept. So negative 0.0185x plus 1720. And then put 150910 on the other side. Now that's 1720. If you think of this as y equals mx plus b, what's that 1720? It's like my what? B, which is my y-intercept. 1720. Is negative 10 to 10 going to be okay for this window? Alva, what do you think?
No.
No. What should I set my y max to?
Something around 1720 or above.
Yeah, just go a little above it, maybe even 1800. That's more than you need. Now, we said earlier that this is an investment where he's making money. He's not going to lose money. So having a negative y value doesn't make sense. And what was the least amount of money that he could invest? Yeah?
Like $1. Or no.
No, He could choose to put no money in one account and put all 20,000 in the other account. So he could put no money, and the most he can invest is, well, how much money does he have? 20,000. So let's hit graph. There's your left side. There's your right side. And just like Declan said, we want to find where they cross. So second, calc, intersect. Remember, to do an intersect, you just have to hit enter 3 times. Okay. So how much money did Bill invest at the 6.75% count? Well, how much money did he invest?
He invested, what was it?
It's up there.
Oh yeah. Wasn't it? 11,400.
He invested 11,400 in the first account, and he had a total of $20,000. So how much did he invest in the second account? Yep.
8,600.
Yep, 8,600. Yes.
Could you show what you entered again to get the graph?
To get the graph, yep, we did second, calc, intersect. We hit enter on the blue.
Oh no, I meant like with y equals.
Oh, the y equals. Right. All right. So let me just put up a few reminders about what's going on for tonight. Okay, so normally that would have been the homework, but we're going to do the take home. And that's going to cover everything from this week. So that is 1.3 part 2 up to what we just did. So when you're looking on Edge Elastic, you're going to look for the take. It'll be the only thing you see anyway. But it's going to be the test on those sections. What else? So you will have 50 minutes to work on it tonight. Those 50 minutes do not have to be consecutive. You can do 10, close it, come back, do 10 more. But don't leave it open if you're going to break it up. So you'll have 50 minutes tonight, and you'll have class tomorrow as well. How much time tomorrow? I don't know. It depends on how many questions people have for me at the beginning. So it will be due at end of class on 9/23. If you choose not to work on it tonight at all, okay, it's up to you. But you're only going to have 30 minutes tomorrow then to do the whole thing. And you will not finish most likely in 30 minutes. So I would definitely work on what you can tonight. There is no homework in the book. Yep.
How many questions is this test?
I don't remember how many. I think it's around 16 questions. I think it's around 16. Does anybody have a concern about being able to work on it tonight? Don't have internet, don't have time. Yep.
I have my EMT class tonight,
Okay.
so I'm not going to be home until like really late.
Okay.
So I can try my best. I just like.
So if you don't think you're going to have time to work on it tonight, then I can give you 50 minutes at some other point to do. Yeah,
I might not have a working calculator for it.
you can use the one on the website.
I don't have my Chromebook.
You don't have your Chromebook?
Yeah, I don't know there.
You'll have to. You can set it up on there.
I might have one. I had to order a charger for mine.
Yeah, you can set it up on any computer.
Okay.
The graphing calculator. Just watch my website for how to do it. Just like we did the first day.